12, and they're asking which three go together. Okay, and so I'm going to, come down here, and I'm going to put some responses down below these triangles. So down here, we see that AB and C go together because both triangles in each pair are scaled copies, and both triangles in each pair are dilations. Okay, down here we see that A, B, and D go together because both triangles in each pair are facing in the same direction. We see that A, C, and D go together because none of the triangles in each pair overlap, and none of the triangles in each pair share a common vertex. And then for B, C, and D, we know that both triangles in each pair are different sizes. Okay, so there you go. Now for the next one, I'd like you to also look at the digital version of this, okay? But I'm going to go ahead and also give you some information to look at, okay? So, let's do it here. So what we can do for this one is we can begin with L, M, E. Okay, we can then translate L to E. Okay, and so let's go ahead and do that in red. Okay, so L to E. So if I do that, I'm going to have a triangle that is here, and then that goes up to here. Okay, and then here. Okay, so there's my translated triangle. Okay, and then what do I need to do? Next thing I need to do is, I know that this is 2. Okay, and this one is 4. So what I need to do is I'm going to dilate using E as the center with scale factor 2. Okay, so that's how we can do number 1. Let's do number 2. All right, so what we can do here is we can begin with A, B, C, D, E, and F. Okay, so we're going to start with the small one. Okay, then what we can do is we can reflect using the line that contains, sorry, that's really too small. A and F. Okay, so we're going to reflect around that. Okay. And then we're going to translate F to I. Okay, and so what we're now doing is we're taking our reflected shape and we're moving it here, right? And then what we're going to do is we're going to dilate using I as the center with a scale factor of 3. Okay, so you're going to need to measure. So what we do maybe is measure oops, sorry about that. Let's go ahead and put our ruler. Okay, we're going to rotate it and then we're going to move it. Okay, so it looks like it's about a centimeter. Okay, and when we come here, it's close to 3. All right, so remember these scales are a little off. So you can get a little bit more precise. Your text is probably different than the digital version, okay? And so that's how we're going to do number 2. Or are you ready for more? We are not going to do that. Okay, so let's do 12.3. So for 12.3, let's look at a square and a rhombus. Priya says these polygons are similar because their side lengths are all the same. Claire says these polygons are not similar because the angles are different. Do you agree with Priya or Claire? And then explain your reasoning. Okay, so I'll go ahead and get that in there for you. Okay, so one of the things to remember, okay, are the similar polygons. The angle measures have to be the same. Okay, so they'd all have to be 90. So even though the sides are the same, the angles are not. And so these are not going to be similar. Okay, now let's look at number 2. Jada says these rectangles are similar because all the side lengths differ by 2 inches. By 2. Lynn says these rectangles are similar. I can dilate AD and B to C using a scale factor of 2 and AB and CD using a scale factor of 1.5 to make the rectangles congruent. Then I can use a translation to line up the rectangles. Do you agree with either Jada or Lynn? Okay, and then explain your reasoning. Okay, so for this one, we're going to disagree with both of them. Jada is right that the side lengths all differ by 2, but the scale factor needs to be the same for 2 rectangles to be similar. Lynn is incorrect because the scale factor for dilating one set of sides cannot be different from the scale factor for dilating the other sides. Okay, so just a couple more definitions of similar. Are you ready for more? So we are going to skip the are you ready for more here, okay? All right, so now your teacher will give you a card. All right, so for this one, if we have the cards, go ahead and work on that. If we don't have the cards, then that is okay. All right, let's see. Let me go ahead and put down some answers for you. Okay, so I went ahead and put the information down here. Okay, so, sorry. For this right here, the information down here at the bottom. Okay, so you can take a look at that. Okay, and then let's see. For the next one, it says on the left is an equilateral triangle where dashed lines have been added, showing how an equilateral triangle can be partitioned into smaller, similar triangles. Find a way to do this for the figure on the right, partitioning it into smaller figures which are each similar to that original shape. What's the fewest number of pieces that you can use? Okay, so one thing we can do is, let me get to my drawing here. All right, so if we split this in half, okay, what we can do is draw these shapes. Okay, and then we're going to okay, so those are all similar shapes. Okay, can we do any fewer? Okay, so take a minute and see if you can find any fewer. All right, sorry, any smaller. Make these smaller. Okay. All right, so then we have our another definition, right? Similarity. And then make sure to look at your translations, reflections, and all of that information that we've already gone through.